is Ken Levinson. I am the Executive Director of the Passive House Network. We are a national nonprofit, and I'm very happy and pleased to have with me today Lois Arena and Dylan Martello, Stephen Winter Associates, for scaling up all electric buildings. Before we get to the presentation, I want to briefly tell you a little bit about our organization if you don't know. As I mentioned, we're a national nonprofit. We are affiliated with the Passive House Institute in Darmstadt, Germany, and a member affiliate of the International Passive House Association. We work closely with the North American Certifiers Circle around certifying buildings to the Passive House standard. And we have a nationwide membership with various regional chapters. And we encourage everyone to become a member and be active in the community. It's a global community. It's a very generous and giving community. And it's really about sharing that global knowledge capacity, applying it to regional contexts and local needs. We are really all about education, because education is what changes our vocabulary, it changes our conversations, it changes how we think and work with buildings. And we offer a range of educational opportunities and really a full pathway and a lifetime of learning, from introductory courses that we are very happy to share in providing with Building Energy Exchange out of New York, to core certification courses, the CPHD for designers, architects, engineers, consultants, and tradesperson for builders, contractors, and so forth. Specialized, because as you go in deeper and deeper in your particular roles, there's a wealth of knowledge needed there. And then we'd like to think of building certification. While we don't do certifications, we like to enable them and support them, because certifications not only key quality assurance, but key educational aspect. I like to think of it as an apprenticeship, as the graduate school, as really learning by doing. And so important in those first projects in particular, and the first projects of any new type of building. So we encourage you to go look at the courses and take advantage of them. Many of them are now on demand and are very accessible, flexible, and affordable. A couple of brief announcements. I want to note we had a couple of weeks ago a symposium called Regenerative Construction Ecosystems. It was really about bringing together wood and biophilic materials with industrialized construction and passive house. And the combinations were really exciting. It was 6 hours over 2 days. The day one videos are now available on demand. With the discount code PH+WD, they are free. And the day two should be on demand and available by the end of the day tomorrow. If you're new to Passive House, one easy way to get into it, to find out what the hooks are, what's special about Passive House, what makes a difference, is a simple 1 hour presentation that I give one Friday, the second Friday of each month. So this Friday at noon Eastern time. You can register on our website, and it's a nice conversation. It's usually pretty intimate, and really dive into some of the basic aspects of what makes Passive House compelling. We're very happy to have just recently launched the pH ribbon. It is a embodied carbon emissions calculation tool that is embedded in the PHPP. It's not with the PHPP, but it works in with it. It's a plugin to the PHPP. And what it does is allow now for Passive House designers to not only look at the operational energy and climate impact, but also the embodied carbon, and having a whole emissions calculation and be able to make design decisions based on the entire carbon profile of the building in one place in the PHPP realm, which is transparent and pretty straightforward in terms of operating. So we have a training coming up on February 6th, if you're interested in that. March 9th, we have a symposium, a half-day symposium called Fenestration Focus. We'll be looking at scaling up high-performance domestic supply and demand, looking at certifications, the policies, the capacities, and how we can do that. We're really happy to be partnering with not just the Passive House Institute, but also the Facade Tectonics Institute as well. That should be very exciting. And a quick shout out for down the road, save the date, make your plans. Our national conference will be in Boston this year. Passive House for All, Efficiency, Electrification, Embodied Carbon, Equity, the 4 E's. June 10th, it will be all online, live online. And then on the 17th, a week later, we'll be in person in Boston with tours, workshops, and the whole 9 yards. So super excited about going to Boston, being in Massachusetts, and all the activity that's happening there. And one last shout out before we get started. Regarding the education, the CPHD really is the cornerstone. It's learning the language of high performance, and it's on demand. We want to thank our sponsors who we just could not do these events without their support, so critical, and we really appreciate their dedication to high quality, high performance, and pushing the industry forward. So in insulation, we have Owens Corning, Rockwool, and Aero Aggregates. For the enclosure systems, 475 High Performance Building Supply, Rotoblas, and Martello. In HVAC, for the ventilation, we have Zender and Swagon, and Mitsubishi Electric Air Conditioning. Windows and doors, Wythe Windows, Cascadia, Schuco, Intis, and Enersign. And service providers who couldn't do this, architects, engineers, consultants, and so forth. So Bright Power, Stephen Winter, who we're hearing from today, Need-Based Architects, NYSERDA, AHA, and Cube 3. So we thank them all for their support. And with that, let's get on with the program. Very excited about this, this program today. Electrification is, if not the elephant in the room, it is what's staring us in the face. As the grid greens, buildings that have fossil fuel combustion in them will quickly become dinosaurs, in my opinion. And so the push towards electrification to be ready for the green grid is so important. And we're very happy to have the trailblazers here today to show us the way. So Lois Arena, very happy to introduce the Director of Passive House Services at Stephen Winter Associates, possesses over 25 years of experience in the building science field and has extensive experience with new and existing buildings. Lois holds both US and international Passive House consultant certifications and is currently consulting on some of the largest and most difficult Passive House projects in the world. She has co-authored and presented training programs about energy efficient building practices to professionals in all sectors of the building industry and is regularly invited to present at conferences and private firms around the world to discuss the benefits and the roadblocks to Passive House adoption. And I'd be remiss if I didn't also add that she is a board member of the Passive House Network and the vice chair to boot. So we're very happy to have her here. And as well, Dylan Martello is a senior building systems consultant, certified Passive House designer with Stephen Winter, specializing in Passive House and net zero consulting and energy modeling. On a day-to-day basis, Dylan works with project architects and engineers to assist in the design of extremely energy efficient buildings. His direct project experience includes a range of project types from large multifamily buildings, such as 425 Grand Concourse in the Bronx and Sendero Verde in East Harlem, the Winthrop Square, a high-rise office building in Boston, a manufacturing facility in Sri Lanka, and Hotel Marcel, an all-electric retrofit hotel in New Haven, which is appropriate to end on that, as it will be a subject of the presentation here today. So very excited. And with that, I will stop sharing. And Dylan, if you would like to share your screen, and I will take over the admittance role.
Well, hi, everybody. Thank you for having us. We're always happy to be part of these parts of the sector where we're stepping off into the abyss. It's what we're known for. So I'm going to kick it off, and then Dylan's going to take it after a few slides. Again, we're talking about building electrification. We're going to share some of the projects that we have that are going for it and almost done. Okay, Dylan. Next slide. Oh. That's okay. Sometimes the arrows work, sometimes the mouse works. I don't know why the clicking is. It all depends on who's sharing. And as Ken mentioned, we're a full service consulting firm, anything that has to do with buildings and making them. You can go next slide. So here's what we're going to talk about. We're going to do a quick note on electric space heating, summary of options. You guys are probably mostly familiar with that. It's not the elephant in the room right now. We're going to talk a little bit about electrification in the news and in the new laws. Central versus, and then we're going to jump into the problem area, right? Our domestic hot water in this area. So central versus decentral hot water, decision points, summary of the different types of options for domestic hot water. And then we're going to jump into the nitty gritty of our projects that are actually attempting to do this. Next slide. And then at the end, if there's any really technical questions, we do have a bullpen of slides. It was just too many slides to go through in this amount of time. So space heating, let's just jump into this one because I think most of you are familiar with this. Our basic options that we see regularly in our projects are VRF, right? Variable refrigerant flow, air source heat pumps, usually. And most of the time we recommend heat recovery so that you can do simultaneous heating or cooling. And then you can also have the option if you don't have the some of our projects get it VE'd out depending on budgets. You can also run VRF without heat recovery, where you're either in heat pump mode or in cooling mode. You can also do one-to-one heat pumps and mini splits depending on the height of the building. And then there's the water source heat pump options for hydronic loops. So you can do a low temp hydronic loop with an air to water heat pump that charges that low temp water loop and then feeds water source heat pumps or hybrid fan coil units in the apartments, or you can do geothermal wells that provide the boosted temperature in the water loop. And then again, you can use water source heat pump terminal units in the apartments or in your spaces. I always think multifamily, sorry. So electrification of space heating, cold climate applications. We are using VRF on many, many large scale passive house projects right now. And we are using one-to-one heat pump mini splits. We have many operational swap projects that are using these. They're generally confined to up to 8 stories still. Is that what, 6 to 8 stories, depending on the refrigerant. Mid-rise, yeah. Yeah. Mid-rise. Yeah. And then we see some water source heat pumps. We have one project that is attempting in late design to use a low temp hydronic loop with water source heat pumps and hybrid fan coil terminal units in the apartments. And we'll go into that in a little more detail. And then we have a few projects that are actually putting in geothermal systems. They're working very well and the developers like them. They know how to do them and they're following through with those as their electrification option on their future projects. And we'll touch on some of those.
Thanks, Lois. So yeah, so I want to quickly just touch a little bit on sort of some electrification, particularly on domestic hot water, because that is sort of the elephant in the room is domestic hot water particularly. And if you're in the sort of New York City region, a lot of you are probably already familiar with this, but for those that might not be, there was a law passed, the 2317A. There's a lot in that law, and this is by no means a summary of this law. It's just meant to pull out the specific sort of end goals or takeaways as it relates to domestic hot water electrification. So for buildings less than 7 stories, they must have electric domestic hot water by the end of 2023. So the end of next year. That is very quickly approaching. And these are at the time of permit filings. For buildings that are greater than 7 stories, they have a few more years of sort of buffer. But by the end of 2027, this law requires that all buildings greater than 7 stories must have electric domestic hot water. There are some exemptions to this, of course. We have commercial kitchen, which could have some challenges there for electrification, and obviously emergency use and things like special use building types like labs might get some or will get some special considerations for that. But it's not just New York City that's doing this. Boston City Council has voted to ban fossil fuels in large buildings by 2050, and honestly, they are sort of writing in stretch code and updating stretch code in a manner that is going to be very aggressive in terms of building energy consumption, and particularly sort of lean in towards how to electrify even before 2050. And we see it on the West Coast too. So Denver, the city of Denver has also voted to go all electric for large office and multifamily buildings by 2030. So there's really some impetus to electrify buildings, not just as it relates to energy savings and carbon savings, but also it's quite soon going to be the law. So we have to be prepared for that. So when we talk about electrification of domestic hot water, there's so many ways that you can sort of do domestic hot water, and I wanted to really quickly just highlight the big decision point that I think is a key factor in this, and that's whether or not the project goes with a central system or a decentral system, or you can even think about things in a semi-central way. So what are the common decision points? Honestly, one of the biggest decision points from our experience has been, what is a developer used to doing? What are they used to installing in their other buildings? And many times developers or designers don't want to sort of deviate too far from that. So that's usually one of the biggest sort of first questions that we'll ask. But typically what it comes down to is metering, and how metering sort of plays out for domestic hot water. So will the owner pay for domestic hot water? Do they have to pay for domestic hot water? Do they really want to push that cost onto the tenants to pay for domestic hot water? That's a huge question, and it usually is one of the biggest factors into determining whether or not a system is central or decentral. It's not usually like, what is the most efficient option? Like, that's never usually like on the developer's mind for energy efficient option. Let me put it that way. Cost is certainly important, but this is what we've been seeing. But some other decision points here are, do we have space for all these things? Like in a central system, we need a domestic hot water or a boiler room for the building. And do we have space for that? And sort of jumping ahead to one of the other points here, if we need to put this on our roof, does our roof have enough structural capacity, or how do we build in that structural capacity on our roof to actually handle a boiler room and storage tanks? Water heater closets in decentralized systems are a big question. So for decentralized systems, you have a water heater or a heat pump water heater, whatever it is, that will need space for its equipment. And obviously, if it's a heat pump, it also needs space to pull air, and it needs adequate air volume. So that's can have a big space implication. Or if you're doing a semi-centralized system, or conceptualizing doing a semi-centralized system, you need to provide a smaller-ish boiler room on every floor. So that can have a big impact as well. And then lastly, I think a big question here as it relates to centralized or decentralized system is, do we need to future-proof for all electric, 30 years from now, or whatever that may be? Do we need to future-proof our building? And, what we found is that, if you're doing a centralized system, typically it's easier to future-proof than a decentralized system. If you're installing gas lines throughout your whole building and doing gas risers for each apartment stack and things like that, it's going to be a lot harder to electrify than if you just sort of package that into one central location. So this is just sort of summarizing essentially the pros and cons here in a very high level, but obviously the goal being that we want to produce our domestic hot water with a centralized system. Metering is a big question here. So typically what we've found is that if it's a central system, the building owner will either pay for domestic hot water in the building, or they have to pay for twice as many meters and maintenance of those meters to monitor the hot water and the cold water going into each apartment. So that can be a big decision point, and that's why metering is such a big factor in this decision. With central systems, though, there are a lot of different design approach options, and as we'll get into in a minute, you can sort of integrate it to your space heating and cooling systems and do it in very creative ways that really utilizes heat recovery, especially in your summer seasons when you need to produce hot water, but as a result of that, if you're doing it with a heat pump, you're going to be producing cold air. So you could also sort of, or cold water. So you could utilize that to your advantage. As I mentioned before, it tends to be more future proofable. But with the decentralized system, really the tenants will be paying for domestic hot water, and that's one of the big factors there as it relates to metering specifically. But one of the things that's interesting about decentralized approach, and I think there's some merit to this, is that we have seen some data that suggests that when tenants are paying for their own hot water, they tend to use a little bit less water, and that could mean a lot in terms of efficiency and carbon emissions reductions, as well as sort of cost and energy savings. The other interesting thing with decentralized systems, though, is that in many cases, tenants have the ability to operate these water heaters. And in the case of decentralized heat pump water heaters, what we found is that some tenants will take it upon themselves to adjust these heat pump water heaters or switch it over into electric resistance mode, which can be a problem. So, we'll get into all that in a minute, but decentralized systems, you got to be careful, because that's where tenants can start to tweak and tinker with stuff. So that's, domestic hot water is one example of that, but it can be in other applications as well. But I think one of the benefits moving to semi-central is that it could potentially open up the door for some mid-sized water heater options that maybe are more tried and true in the market, as opposed to some of the larger commercial scale units that we're just starting to see come online right now. But the big trick with semi-centralized systems is that you're going to be eating into a little bit of space on every floor in most cases, and specifically in like urban environments where affordable housing is important. That could be one apartment per floor that needs to be negated as a result of that. So that could have a huge impact. Okay, so let's start to summarize some of these options for domestic hot water. So when we look at centralized systems, the first option that we have here that we'll talk about is air source heat pump water heaters. So this is where you have either a large commercial scale rooftop unit on the roof, or you could do a plant style, or you can gang units together of smaller units to create one air source heat pump plant. And that heat pump water heating plant or unit will produce hot water from the sort of outdoor ambient environment and convert that into hot water. So in that scenario, we do need to be cognizant of cold climate performance, and that's where sort of the rubber meets the road with these units, is how do they perform in cold climates, and sort of particularly the Northeast region is what we have experience with. Now, some of our other options, and this is where things can get very creative, is on the water source side. So we have, in an existing building, this is where I think this could potentially play a huge role, is if an existing building, if they have an existing boiler plant and chiller plant that's producing hot and cold water for a hydronic system and hydronic space heating for the building, we do have the ability to tie in water source heat pump water heaters into that existing hydronic loop and steal heat from that. Now, of course, that would need to be sort of coupled with just adequate due diligence, and sort of making sure that we're not eating into too much of the capacity of the system, and because we are going to be stealing heat from that hydronic loop, we want to make sure that the space heating needs for the building would still be met as a result of that. But it does have the ability to provide some heat recovery in the summer and reject cold water back into the hydronic loop, and as a result, sort of utilize some free cooling potential there just to make our hot water for the building. But this sort of dovetails nicely from the existing building scenario, where if when you have an existing boiler plant and chiller plant, if that needs to get upgraded for space heating, what you can do is you can upgrade that to an air to water heat pump hydronic plant. So you'll have a rooftop unit that will utilize the outdoor ambient environment to produce hot water for a hydronic loop that's providing not only space heating to the building, but now also domestic hot water. And when you do that, you can have the ability to do what we call sort of like a low temp hydronic loop. So if you have heat pumps in the actual apartments that's utilizing air from, or utilizing the water from this hydronic loop, you can sort of maintain a fairly mild temperature, somewhere maybe between 70 and 100 degrees Fahrenheit, or 70 and 90 degrees Fahrenheit, roughly, in that hydronic loop that's just running sort of around the building. And then in the apartments for space heating, you'll have a sort of a water source heat pump that's providing space heating to each apartment. So when you have that hydronic loop, you're also now able to utilize a heat pump to sort of, again, kind of take heat from that loop and produce domestic hot water to the building. So you can do that with a centralized system. So there's a lot of heat pumps in that system, and that's describing this as a challenge. But I think this is where sort of the creativity comes into play, and we're sort of thinking about moving our heat and cool air and water throughout the building in creative ways to sort of maximize efficiency. And as I get into a minute, we do have a project that is actually doing this, so we'll talk about this in a second. And then to sort of round out the central options, you have the last two options here are also very interesting. So one, you could sort of do a geothermal loop or geothermal wells with a water source heat pump tied to that to provide domestic hot water. And then in the case of the fifth option here, C5, we do have one project that consists of two buildings that Lois will talk about in a little bit here that utilizes wastewater heat recovery for a central system and utilizes heat from that wastewater to produce about 90% of the domestic hot water load in the building. And then as a result, the last 10% is actually covered by geothermal wells and loops that are primarily there to provide space heating capacity to the building. So this is a very innovative approach that we're seeing as well. So now to sort of move on to the decentralized systems, I wanted to put electric resistant tanks on here. I know this is a fairly contentious topic, but I think when we think about decentralized systems, one, we have to think about first off, the point I made before that we might be using less actual water consumption as a result of decentralized systems. And two, right now, the alternative options have a lot of drawbacks. Heat pump water heaters in apartments have a lot of design challenges and potential drawbacks that make the sort of the application of these a bit challenging. And what I mean by that is that the heat pump water heaters, you have sort of an integrated tank heat pump water heater that goes in each apartment. Those heat pump water heaters are, one, they're noisy, and two, they will reject cold air back into the apartment. That could cause some issues as it relates to sort of occupant comfort. And what we've seen is that we've had multiple projects that these integrated tank heat pump water heaters were installed, where the tenants were going in, they were either complaining to the super, and the super was coming in and switching them to electric resistance mode, or they were switching them themselves to electric resistance mode. So when we're doing an integrated tank heat pump water heater strategy in the apartments, we have to be really careful about how they're designed and make sure that comfort is sort of thought about, because in essence, we could end up turning them into electric resistance tanks, and we want to, sort of make sure that we're just aware of that. But I think there is a legitimate case to electric resistance if you can sort of couple that with PV, or think about how you can sort of offset that energy consumption with renewable energy. But that said, we found that certification to the pass-fail standard, because the certification paths are thinking about the grid getting greener and electricity production on the grid scale being a lot more carbon efficient. We are seeing that electric resistance tanks in many cases can actually be a strategy that will work for pass-fail certification. So these are all just factors to consider. But one interesting approach that we have also looked at was, if you had an integrated tank heat pump water heater, but instead of rejecting the cold air into the apartment, rejecting that cold air into the corridors. So in that case, you're able to better soundproof the closet that it's in, and maintenance will now be sort of accessible from the corridor side. And lastly, you're rejecting that cold air into the corridor, which in the wintertime, people are usually wearing jackets when they're walking in the corridor, or if it's in the summertime, people will enjoy feeling that cold air. In most cases, they'll want to feel the cold air in the corridor. So I think there's certainly some merit to this strategy. But you just need to make sure that you have enough heating capacity in the corridor spaces specifically, because you are going to get that cold air in the wintertime. And then lastly here, there's some semi-centralized approaches where you could do one air source heat pump water heater per floor. You could also think about doing this on a per riser or per stack basis, where you locate the heat pump water heaters on the roof. Or you could locate them if you have, let's say, like a below grade or ground level parking garage that you could utilize some space there. You could potentially do an air source heat pump water heater, again, per riser per stack, with the water heaters located at the sort of base of the building. So these are just some different approaches here and different options that we have to electrifying our domestic hot water. Now, solar thermal can also work in many applications. We didn't sort of feature that as part of this presentation, just because we wanted to focus sort of on the heat pump associated systems mostly. But that is certainly an option that can be considered and could potentially work. And we have a couple of projects that are doing that as well. All right, so let's get to the meat on the bone, the projects that we have in operation or design and case study of cold climate applications. So here's a quick summary at a high level of sort of the numbers of projects that we have, and then we're going to dive into sort of one by one talk through of each of these projects. So on the air source heat pump water heating side, again, this is where cold climate performance is really pivotal. We have 5 projects in total. 2 have recently been operational. 1 is in final commissioning stages right now, and then we have 2 in late design. We also have 1 project that is utilizing the water source heat pump water heaters tied into the low temp hydronic loop system, and that's in late design. So we're excited that that one will be wrapping up design soon. And then we have a couple of projects. We have 1 project that we have water source heat pumps tied to geothermal wells and loops. We have 1 project. I think this is actually a mistake, but I know for a fact we have 1 project in late design where we have water source heat pumps tied to the wastewater heat recovery system that Lois will talk about in a minute here. Okay, and then on the decentral side, we have a lot of projects that have electric resistance tanks. That's certainly not a new technology. We have a handful of projects that are using the integrated tank heat pump water heaters with cool air being rejected into the apartments. And this is where, we're learning a lot of lessons. Unfortunately, they're not being utilized to their best capacity. So this is kind of a good learning experience. And then we have 1 project that's in early design that's considering doing this idea of projecting the cold air to the corridors with the heat pump water heaters sort of on a decentralized basis. But we'll see how that progresses. But I think it's fairly promising in the early stages. And then we don't have any projects that are doing semi-central. It's really just the space issue is the big concern there, eating into potential apartments. So, all right, so let's move into cold climate applications case studies here. So I'm going to hand it back to Lois to talk about this first project.
Dylan, I just added a note that the semi-centralized systems don't usually go in our projects in New York just because square footage is so expensive. So they're either put on the roof or on a podium space. So that's kind of why you don't see it on each floor. So here's this is a really exciting project. This is a project that is 5 or 6 phases. We're in phase 1 right now. The builder is L&M. I hope they don't mind me calling them out. They're a wonderful builder, and Apex is their partner. And they're doing 2 buildings in this first phase. One is 340 something units. The other is 123 units. So the smaller building in front is C2 and the larger one in the back is considered C1, C2. I mean, sorry, the small one in the front is C3. And so they're new construction projects, they're affordable multifamily housing projects, they're in late CDs right now, and they're slated to start construction pretty soon this year. And this is one of our projects that's gone with the domestic water heaters with wastewater heat recovery, right? So they're doing, and they're 2 different systems from the same company. The first one on the large building is called, it's a actual water source heat pump that is paired with what's called the Shark system, which is a waste stream heat recovery system. So that tempers the water in the incoming water loop. right? So we're drawing it. Imagine it's like a geothermal system. Instead of drawing in the heat or the cool from the ground, you're drawing it from the waste stream, which is most times of the year a very constant temperature, right? So fairly reliable as far as weather conditions go. It's not really affected by our weather here. So the water comes from that system where it's boosted to a Colmac air water to water heat pump that boosts the temperature of the water the rest of the way up, and that goes into the storage tanks. The smaller building has what's called the Piranha System, which is also from the same company, which is that's the system that I said is like a geothermal. It has a heat pump that is pulling the waste the heat from the waste stream and boosting the temperature. So in the first one, you have a tempering system from the waste stream to an actual water to water heat pump. In the second one, in the Piranha, that's actually a heat pump water heater that is pulling its heat from the waste stream. Okay, we have a couple diagrams. We'll show you. I don't want to dwell on it too long. And honestly, this is the first time, our first big project that's actually in design with this in CDs. And so the details, you may have a lot of questions on this. I may not be able to answer them, but I'll take them back and get answers for you if I can't answer them. So up in the left-hand corner, this is building 1. That's our waste stream recovery system that's boosting the incoming water. And then it goes loop into the building loop. There's one major water building loop, right? That's getting boosted. And sorry, Dylan. And it goes down into, if you're looking in the right bottom corner where that's where the Colmac system is located, that boosts it the rest of the way and sends it to the storage tanks, which then goes off to the domestic hot water taps. Okay, so this is a system where we have a separate heat pump from the heat extraction from the waste stream. On the next screen, you'll see, all right, so this up in the green, everything is integrated up there. So our heat pumps are actually drawing heat. There's a refrigerant line through the waste stream that's withdrawing the heat from that, and they're using that temperature and boosting it up into the water tanks, into the storage tanks up in the upper left, which are then going off to the building. Okay, so this is more of an integrated system all in one as opposed to the previous one. Really interesting system. And I have to say, most of our passive house builders and our longtime developers who know they need to go electric are very, very interested in finding out more about these systems. So we'll let you know how it goes. Dylan?
Yeah. All right, so as Ken was alluding to earlier, Hotel Marcel is a project that is existing building retrofit located in New Haven, Connecticut, right next to I-95. So that's this road here, and it's a large building, 151 hotel keys, so it certainly has scale to it, and it is just about wrapping up construction right now. We anticipate final testing on the building in March. And we're looking at sort of probably soon after that in April occupancy, and we can start getting some good data back. It is sort of undergoing the commissioning phase right now. So we're like right in the middle, in the heart of it right now in terms of getting the system up and running. And they're using the centralized, they're going with the central approach, air source heat pump water heaters. Specifically, they're using the Mitsubishi QAHV units. And they do have electric resistance as supplemental heating for backup in case the heat pumps need the extra capacity. So we do have a quick a diagram here, not so quick, but essentially what we're showing here is just the outdoor QAHV Mitsubishi units, and there is some heat tracing on the piping on the outside of it, just to kind of deal with the outdoor pipes. I think one issue that I've heard with the Mitsubishi units is just challenges dealing with defrost, technically speaking. I'm not sort of as experienced on those specific challenges, but that said, the heat pump itself is efficient and a good unit. So yeah, and then that gets sort of piped into the building here, and then it goes to water heater tank plant that's not shown here in the schematic that will that eventually gets distributed throughout the building. One of our other projects, this is a retrofit of an existing building as well. This is with NYU, Rubin Hall, and they're looking at doing water sourced heat pump water heaters with a low temp hydronic loop. So this is, again, a large building, 258 apartments. They're apartment style dorms. Right now it's in late CDs, and construction is anticipated sometime in late 2022. And they are going for domestic hot water. They're going with the Colmac CXW system. So for the low temp hydronic loop, if you recall me sort of fumbling through trying to describe this, you have a air to water heat pump on the roof that is providing heat or cooling depending on what the low temp hydronic loop needs. Essentially, it's just tempering this loop, right? That air to water heat pump is, I believe, an AirMech unit, and that is tempering this low temp hydronic loop. And then they have fan coil units on this project in the actual apartments that's providing the heating and cooling, space heating and cooling to the building. And then the Colmac CXW is stealing that heat from the low temp hydronic loop and using it for the domestic water heating for the building. We do have one project that is operational. This was an existing project that is a 60-unit multifamily building in New York City. And the strategy was to essentially go for a displacement strategy. So essentially, instead of providing 100% of the building's domestic hot water load and fully electrifying, this was sort of like a pilot project test case study to see how well these sort of heat pump water heaters work. So these are air source heat pump water heaters. They're using the Sanco 2 units, and there's 14 of these heat pump water heaters that are located on the roof here in this sort of section of the building, sort of near their PV system. And this system has been recently operational. It has sort of gone through a fairly long commissioning process and is still sort of ongoing. So we don't have any sort of data right now that we can share, but we do expect to hopefully get some good data this year on this exact project. Okay, so now some new construction projects. So we had two projects, both developed by Hudson, who another one of our good clients that is sort of forward thinking in this regard and is taking two of their projects to two of their buildings to fully electrify. One is Cooper Park Commons, their building 2, which is a 310 unit building shown here in the top right, and then La Centrale building C, which is a 168 unit building. Both are in late CDs right now with construction anticipated, likely 2023. And the domestic water heating strategy for these projects or buildings are both air source heat pump water heaters, centralized systems, and they're using the Link by Watts Aegis A units. All right, this project, Northland Newton, is another interesting case study. So this is a series of multiple buildings, upwards, I think, of 9 now that are being designed to the Pass-Fail standard in Newton, Massachusetts, that are again going all electric, and they are actually right now the design strategy for domestic hot water is actually a decentralized approach, and this is sort of where we sort of got into these discussions about metering and really the client is used to doing decentralized systems and they're used to the tenants paying for hot water. So we tried to sort of accommodate a design that worked with those needs, but also met the Pass-Fail metrics. And what we found is that electric resistance tanks actually do comply with the Pass-Fail classic standard when you're looking at this under the PER framework. And that's because the PER framework, for those that are familiar with the certification standard, does assume sort of a green grid, essentially, decarbonized electric grid. So we see less of a ding on the primary energy consumption of the building when it's an all-electric building. So because of that, electric resistance actually is a strategy that works for compliance. Now these are being coupled with a PV-ready roof that either on day one or sometime later in the projects life will, start to offset that energy consumption with renewable energy. But this is an interesting case study, and I think one that is, worth highlighting here. And this project is in mid-design right now, and we do anticipate hopefully construction starting sometime next year. So, this would be a really interesting case study to, maybe try to monitor hot water consumption and see if it's anything less than what we're seeing on some of our centralized systems. And then one last project that I want to highlight here is that this is actually a project that SWA isn't on, but we want to give a shout out to Tatum Engineering for looping us in on just sort of filling us in on this project that is operational, where it's a multifamily building. The number of apartments is losing me, but I think it's definitely over 100 apartments, and they're using Sandco units as well in a plant style with electric resistance backup. And it is in operation, and they have recently started to get some good data back that's sort of showing that it is performing up to par for what they were anticipating. We did get some feedback on lessons learned from them, from Tatum specifically on this, and that being that they would do this again. The one thing that they would do a little differently was just sort of dealing with the layout of these heat pump water heaters. So with the stand-in units, they were actually installed sort of hung from the exterior facade of the building, so hung on a vertical wall assembly. And essentially what you have to be careful of is when you have units stacked on top of each other, you can have snow melt and ice melt coming down on other units. So they would have sort of tried to address that strategy a little bit differently, but they did sort of kind of come up with a retrofit approach to help deal with that issue. But that is one thing that was a good takeaway from this. But the highlight here is that it's operational and it's actually performing well in a cold climate application in Ithaca, New York. So that's really, really promising to see, and I think we're really excited to be a part of and aware of. And just sort of embedded in this new trend that we're seeing. So so having said that, we have about 12 minutes left. So I think we wanted to sort of open this up to questions and discussions. We know this is a huge topic. As Lois mentioned before, we have sort of a bullpen of slides that get into sort of the nitty-gritty diagrammatic stuff. If we wanted to talk about more specifics about any of these sort of schematics, but we wanted to kind of see where you guys are at with this topic.
Yeah, it looks like we have a few questions coming in here, Dylan and Lois. One here, how would you design these domestic hot water systems for warm and hot climates like California?
The heat pump water heaters are really beneficial in those areas. The package ones, you can throw them in a garage, you can put them in a closet in the house and benefit from the cooling side of it, as long as you duct it properly. It's not just that they just need airflow over them to operate, right? So you need to make sure you have proper airflow, and you need to make sure that they're not ventilated badly, like from an unconditioned space of your house that's going to increase your cooling load. So there's definitely there, and they're used widely out in the Northwest and the West, the air to water heat pumps.
Right, so they're pretty familiar.
Yeah.
In locating these, there was a question in the chat about putting them on the outside of the building, the decentralized units. And you remarked on the issue with snow and dripping and whatnot. Has there been anything where you've seen, we've seen heat pumps on balconies and other things like that, or architecturally speaking, I don't know, is that cutting into floor area essentially that becomes problematic? Or
like the ones we did at Cornell? Yeah, so when you're doing that, those were for heating and cooling, right? So they're quite large. I'm not sure that it could be the heat pump water heater might need to be bigger. I'm not sure, but it's the detailing of that little porch is pretty intense. That's a pretty expensive little porch, So if you don't have to do that, if there's another way around it, I would recommend it.
Yeah.
Yeah.
Fair enough. There have been a few questions about the waste recovery, the waste heat recovery systems, in terms of what type of performance are you expecting to get out of that? I guess the payback, so to speak, and as well, just as yeah, part and parcel with that and its performance to kind of extend the capacity, if that's the right way to think about it, of the heating system.
So the Shark system and the Piranha, they have rated COPs of well above 4. So they become very cost effective. Actually, there's also very good incentives out there, especially in New York, for heat pumps through NYSERDA and through the Clean Heat program. So makes it very, very doable as far as the cost of the system. The mechanical engineer that's working on the one that we're working on right now, Cosentini, right? They're a conservative engineer. They're a big firm. They're reputable. They don't go jumping off cliffs for things that, they think are going to come back to bite them. And they're feeling pretty confident about the performance and the data that they've seen so far.
Yeah, I was interested in the L&M project where the two different systems for the low rise versus the high rise. And was that were there characteristics about that were inherent to a high rise versus a low rise, or
I
the
think it was
scale of the building? Like what
it was
pushed?
the scale. It didn't really have to do with the height, Ken, because they're both located in the basement. It has to do with the peak load capacity of either of those systems. So the Colmac has a higher peak load capacity per cubic foot of what it's going to take up. So yeah, they're definitely a different strategy because of the peak load, because of the occupancy of the tall building compared to the lower one.
Got you. And I'm curious, not to get into the weeds of PER, it's a whole other ball of wax, perhaps, going in the certification, optimizing to this future decarbonized grid. But when you're going through the certification process and looking at optimizing the building, what kind of characteristics, or what are you seeing as tripping points that would say, oh, well, yeah, we want to go with resistance heat? Is it a combination of things, or?
I think it's, just hesitancy about the drawbacks to integrated tank water heating plants and lessons learned from the field, where they're just getting, for the most part, they're just getting switched by owners and tenants to electric resistance mode.
Right.
Which, why
They're
invest
paying
in it? So yeah, so I think what's important to note as sort of a parallel path in this discussion is really investigating the feasibility of ducting the air to the corridors, because I think that could be a very promising approach to addressing the comfort concerns specifically with those units. So it's really just the drawbacks to the comfort and sort of them getting switched to electric resistance.
And I'm sorry, Ken, there was a comment in the chat too that asked if we had investigated ducting them to the outside.
right.
And I would say no, we haven't investigated that. The only little bit of information I could probably give you is that architects are very reluctant to give up the outside wall at all. And sometimes ducting from an interior wall all the way to the outside is an expensive venture.
Right, it's another penetration, right?
Yeah.
Plus, you'd have to provide makeup air in that scenario. Because if you're
right. So you would be pulling it from the apartment. Yeah.
Right. So that adds to your losses there.
Yeah.
So there's a question about the retrofits, the retrofit projects, and looking at switching over from historically fossil fuel buildings to electric, and the kind of inherent challenges around that, with the equipment, the capacity, the electrical capacity, presumably upgrading. What are you seeing in the NYU and the HPD buildings?
Well, as Dylan mentioned a few of them already, like the space is 100% an issue, especially if they're trying to change both heating and domestic hot water systems over, where are they going to put all those condensing units if they don't have a podium roof as well? So, you know, space is a huge consideration, because you also need more storage than you would need if you're going from an air, you know, a gas system to an air to water heat pump. You need a lot of storage so that you can handle your spikes aren't too great when the peak load is happening in the building. And then electrical capacity. Do we have enough electrical capacity to the building, and do we have enough electrical capacity to the roof to run the heat pumps, to run the pumps, any extra pumps that need to be up there and things like that? So when you look at Reuben is a tall, kind of thin building, and we're trying to put in heat pumps for the heating and cooling, an ERV to handle the ventilation, right? Because they're designing it to EnerFit, and then the domestic hot water. So it is tight up there, and it's historic. So you can't see any of this stuff from the ground, right? So like you're battling all angles on that project, and they're really doing a great job trying to figure it all out.
That's fantastic.
Yeah.
When did you want to add something, Dylan?
Yeah,
or-
one just last note on this is that I think this is why it's so important to implement strategies to reduce loads in the building, both on space heating and space cooling. Space cooling is a lot harder to reduce those loads, in my opinion, than space heating, and domestic hot water where you can, because as you're retrofitting existing buildings, in order to not sort of trigger any sort of upsizing of electrical capacity, when you do electrify domestic hot water, particularly in space heating, you want to ensure that those loads are kept at a minimum, so that way you're not, you know, turning up the dial on your electricity needs as much as it might potentially need to be. So it dovetails nicely with passive house in that regard.
That's a good point, Dylan. Yeah.
That's great. That's great. There's a question, maybe somebody perhaps skeptical of the Sandin performance and wondering if you provide backup resistance heaters for the Sandin units. What are you seeing for the performance? And
yeah, so for the project that Tatum Engineering was working on, they have electric resistance for backup. And I don't know from their data if it's kicked on that much, but it's been fairly minimal from what.
And that's for just extreme temperature conditions?
Yeah, if it's really cold out, or it's, you know, 8 a.m. in the morning and everyone's showering or something, you know, those sorts of situations. And then for the other project that's using the Sandin units, the existing building that SWA is working on, it's got 60 apartments. They're sort of using a displacement strategy. So there is another heating system in the building for domestic hot water. And they're basically just seeing how much can they offset, what percentage of the domestic water heating demand can they offset via the Sandins, and sort of seeing where that kind of maxes out at, and if there's sort of ideal times to go with the Sandin units over the existing water heating plants. So in that case, there is a backup. I don't know if we have any, I don't think we have any projects yet that are just doing key pumps without any sort of electric resistance backups.
Got it.
Yeah.
Interesting. One question here as we kind of round out things. Focusing on domestic hot water is definitely the elephant, I guess, if there is one, to get our hands around that. And it's fascinating to see all the different ways to tackle it. We have not talked about cooking.
Yeah.
And is it becoming a non-issue? It's just like you're getting induction. And, you know, a number of years, not that long ago, it was like hackles were going up everywhere around induction.
Yeah, well, Hotel Marcel is a great example. They're going with an all-electric kitchen. So we have a
commercial kitchen.
Commercial kitchen, yeah, exactly. Commercial kitchen. It's got 82 seats or so it's a big commercial kitchen, and they're going all electric. So they had to sort of design the menu to sort of be able to fit with the all electric appliances. But that said, the menu is still very fitting. Actually, as part of one of our podcast episodes, I did like a little fun exercise where I made other people sort of place an order at this hypothetical restaurant, and I didn't tell them what the background was. And, you know, no one complained that they didn't have options on the menu that wasn't good. Like they all felt that there was great food options available and it wasn't like restricting in any way. So,
Right.
but I think we can do it. It's just, there's options out there. It's just a matter of convincing people that are used to doing what they've been doing for the last 40 plus years, however long it might be, where they're used to gas.
Right.
But we just need to get people and kitchen people that use kitchen, chefs and things like that in front of induction sort of appliances and sort of the new technology that's out there. I think it's a matter
once
of
you cook with induction, it's kind of, I mean, my opinion is it's like passive house. Once you do passive house, it's really, you can't go back, and induction cooking is not dissimilar. And I want to give a shout out to SWA podcast of a chef, Christopher Galarza, who's a huge proponent of all electric commercial kitchens, and a consult, I guess, on them. And it's a wonderful podcast. He really dives into it on the Stephen Winter site. So with that, I think we've covered the basic the basic basis of going electric from fossil fuels in buildings. So I want to thank you both very much for your presentations and discussion today. Super informative. It's wonderful to see these big projects happening, the retrofits, to know that we're going to see a lot of these different systems up and operational and getting the feedback loops and seeing what's working and what's not. So we look forward to having you back.
A year from now, we might just be sitting here with cocktails. Just,
we have to wait a year,
crying,
Lois?
Crying, yeah. Out of work, I'm out of work. Where's Lois?
All right, I think the work is just growing. Wonderful. Well, thank everyone. Thank you to everyone for joining us today, and look forward to future PHN Presents. And please get to the CPHD On Demand course if you are interested in going further with Passive House, and see you at upcoming events, including our conference in Boston. There will be a lot on electrification there as well. Thank you. Have a great day, everybody.
Bye, everybody. Thank you.
Thanks.
Bye-bye.